Great. Ramkrishna, thank you so much again for joining on time.
Yeah,
How are you both today, Sachin, Ramkrishna?
I'm
yeah,
good, sir.
fine, sir.
Thank you.
Great.
Analyze is fully statistics, right, sir?
Yeah,
Analyze.
it's full statistics, but along with that, some strategic thinking is also there. Like
Yeah.
the today's topic that we are going to learn is a root cause analysis. In that, we can say there is a role of statistics, but it is a more of a subject matter expertise, right? How we are going
Yeah.
to use it in the most appropriate way.
Yep.
The one more thing is like we are going to see what is the detailed procedure, how to do that, and along with that we will also see that how we are going to do that for our model project, right? So for our model project also, we already identified there are three critical or significant factors, right? Or
Yes.
significant causes. Now we are going into the next level to identify what are the root causes of them, right? So but
Sure.
before that, it's very important to understand what is a procedure, right? So I think it's already time, so we can start. Let me share the
So,
screen.
so
Yes,
have you
Sachin.
started? Have you started the recording for this session?
Uh, Let me.
You live onto the YouTube, but just wanted to confirm it. That's it. Nothing else.
Mm, okay, yeah, here it is. Thank you so much. I forgot it. Yeah, recording has started. Great.
Yep.
Thank you
Yep.
so much, Sachin. Raj, glad to see you again on time. How are you?
I'm good, Vijay. How are you?
Yeah, I'm also great. Thank you for asking. And we just checked the mood of everything and what is the health. And now we just jump into the challenge it. Great.
Yeah.
So let me share the screen and let me know if you can see my screen. Can you see my screen?
Yeah.
Yes, sir. Yes, sir.
Okay, great. So as you know, we are entering into the challenge 8. So till the time we had seen important topics from the I can see from introduction, define, measure, and today is the I can see the last topic from the analyze phase where we will go in more detail to understand how we can identify the root causes of the significant causes that we have identified in the last session, right? So this is a challenge 8, and in that we are going to discuss about the root cause analysis. As the name indicates, we already identified what are the significant causes, but it's very important to go into the more detail and understand what are the root causes of them and fix them so that we should not have the recurrence of the problem, right? Now, during learning of this root cause analysis, we are going to cover that into three important elements. And into the fourth element, we are going to summarize like what are the tasks that we need to complete as a part of the challenge 8. Now, let's go into the element number 1. Before to start the root cause analysis, it's very important we should have clear problem definition. If the problem definition is clear, then we are going to direct our root cause analysis in the correct direction, right? Now the question is how we can define the or how we can create the clear problem definitions. So for that purpose, there is a very I can say the simple but effective tool is there. It is called as a 5W1H. In some cases, we are also going to use it as a 5W2H. Now, what is the difference between these two, 5W1H and 5W2H? It's just the one additional element that we are going to investigate into 2H, right? Now, what is this 5W1H? We are going to investigate what is the problem or what is the significant cause that we have identified by asking these 7 questions or 6 questions. Out of that, the 5 questions will be W's like what, why, where, when, and who. Whereas the remaining 2 questions will be how and how much, right? So that's why it is called as a 5W2H. Now, in which situation we can use the 5W1H and 5W2H? So it's up to you and up to the situations as well. If it is, uh, let's say, if you can calculate what is the impact in terms of the financials, then we can use the how much. Or even if you are going to use the 5W1H, that is also more than sufficient because we already created the clear problem definition. Is it clear so that we can take on one example so you'll clearly understood what is this 5W1H with the help
Yes,
of example.
yes,
Is it
Vijay. It's
clear
clear.
about
Yes,
this?
yes.
Great. Thank you so much. So let me share the presentation slide where I have already taken one example. Meanwhile, if you have any questions, please ask me in between as well. Okay. Let the screen appear. Now, while using these tools, right, while we are going to use this 5W1H, the interesting question is, can we use all these Ws like in any sequence, right? So that is a basic question that is asked. So I can say you can use it, but you should always start with the what, right? So the first W is fixed. Other Ws, if you want to change, you can change it, right? But the first W must be what? Can you see my screen?
Not yet. So, Vijay, this is also called three leg five eye analysis, similar, right? Three leg five eye, or
It's not an analysis, right? It's we are
okay,
just going to
root
create the
cause.
problem definition, right?
Hmm. Hmm.
So why it is important to create the problem definition? Because our entire analysis or the next steps is totally depending on this. So if
Okay,
you have the clear problem definition, that means our root cause analysis will move into the correct direction. Else, what will be the problem? There is something else, and we are going to focus on something else, right? So
right.
we will not reach to the root cause of the problem. So that's why it's very important to understand what is a clear definition of the problem.
Sure.
Okay. Okay. Can you see my screen now?
Yes.
Okay. So let's take an example. Okay. So this is an example. In this case, you can see there is one scenario, and in that case, we are going to use this 5W 2H tool, right? Now, as I said, what is the sequence of using these Ws? You can use any sequence, but always start with the what, that will be better. And if you can have the next question as why, that will, I can say, enhance your problem definition, right? So let's take an example here. What is this? The first W, which is what? Defines what is happening, what is problem or what is the situation, right? So that is giving you the more clarity about what is exactly happening into the system, right? Let's take an example for this. What is the issue we are facing in production? So let's say we are having some productivity issue, and for that purpose, we are going to do the root cause analysis. So the first question is what is the issue that we are facing, and we can have the next level of answer for this is the production line is frequently stopping. So this is our problem. So what is happening? Line is frequently stopping. Okay, so we got the first W, first answer. Now the second question that we need to ask is why. It identifies the reason behind the issue, the cause of the situation, right? So this cause is not a root cause, right? This is just a primary cause, I can say, that is helping us to reach to the root cause. For example, what are why are production delays occurring? So if you ask this question to the line is frequently stopping, we will get an answer. The delays are due to machine maintenance issue. So we can clearly see that there is an issue with the machine maintenance, right? So just answering these two questions, we can see we are getting some clarity about our problem. Our problem is our production lines frequently stopping because of the machine maintenance issues, right? Now we can take this problem definition to the next level by asking the question third W, that is where. This pinpoints the location or area where the issue is occurring. For example, where do most production issues occur? If you answer this question, the majority of the stoppages happen in assembly area. So it is very clear now. Instead of focusing on entire line or entire area or entire I can say the production department, we need to focus only into the assembly area because we are having the frequent stoppages into this assembly area because of the maintenance, machine maintenance issues, right? So we can see the problem definition is getting more clear and clear. Now let's ask this fourth W question, which is when. This specifies the time or frequency of the issue, helping to identify pattern. So if there is any pattern, right, to identify that, this 4W is going to help us. For example, when does this production issue most often occur? And if you answer this question, or if you investigate, if you go into the data and we understand what is a pattern by using the the some of the tools. Now, what are the tools we can use that I'm also going to cover in some time? Like maybe you can use the scatter plot, we can use the box plot, we can use the stratification, and thereby we can see whether there is an issue with a particular shift, right? So let's say we got an investigation report as delay happened mainly during the night shift, right? So it is very clear now. There is a problem in assembly area during the night shift because of the machine maintenance issues. Because of that, our production lines frequently stopping, right? So this is the beauty of this tool. We just answered this four question and we got so much of clarity about our problem. Is it clear up to this point?
Yeah, yes, yes, Vijay.
Okay, to everyone. Okay, great. Now let's talk about the fifth W question, which is who, right? Now, who is necessarily, it's totally depending on the situation, right? So we can see here, it identifies who is involved or affected by the situation or who could continue to solving it, right? So depending on the situation, we can select any one of these options, right? But just it is giving you more clarity about what is a person or who is a responsible person during this entire scenario. For example, who is responsible for overseeing machine maintenance? To answer this question, we can say the maintenance team handles this, right? So we need to investigate this along with the maintenance team, right? One more thing here. We are going to answer this question or we are going to ask this question who, not to blame somebody, right? We are going to identify the person who is going to help us to come out of the situation, right? As you know, the use of tool is totally depending on what is the subject matter expertise that is also involved during the application of the tool. So that's why it's very important. We must have the knowledgeable person. That's why we are asking this question who, right? So that we can involve the people during the root cause analysis who really having the subject matter expertise, right? Or who know the situation more clearly than us. Is it clear up to this point?
Yes.
Great.
Yes,
So
Vijay.
these are, thank you so much. So these are the five W's, right? What, why, where, when, who. So this is the best sequence in which you should use the 5W1H. But if you want to reshuffle that, that is also absolutely fine. But try to fix, try to start with the what, right? So that will direct your problem definition more, I can say the effective way, right? Now, once we answer this 5W, then the time is for the 2H. So we can see there are 2H are there, how and how much. Generally, in the many of the cases, I can see the only one H is used. That's why it is called as a 5W1H. If you can also answer the question for the second H, then it is called as a 5W2H. Any one of these tools you can use as per the situations. Now, let's understand what is this how. Explains how the situation occurs, the process or conditions leading to it. For example, how does the issue impact overall production? So if there is the uh, problem into the night shift in assembly area due to which we have the maintenance issues and resulted into the frequently stopping of the production line. But how much impact of it is, right? So we can say that stoppages slow production, reducing output by 15%. So there is a reduction of the output by 15%. That also creates, that also conveys what is the urgency to work on this problem. If it is possible to quantify the impact of this problem in terms of money, then we can use the how much. Determine the extent, scale, or cost impact of the issue. For example, how much does this problem cost? So we can discuss with the finance person, and there is always calculation which is available with the team regarding what is a per hour cost, right? So after investigation or after discussion with them, we can identify what is the exact loss. We can see here production delays are costing 10K USD dollars per month in loss of productivity, right? So once we answer this 5W2H or 5W1H, we will get a complete clarity about what is the problem. This is the first step of the root cause analysis. There are other steps, like we also need to involve the subject matter expertise so that we can drive our entire root cause analysis into the effective or correct direction. Is it clear about this tool?
Yes, sir. Sir, just one question. So
Yeah, please go ahead.
every what, why, everything needs to be
Mhm.
supported by the data facts, right? I mean, data numbers,
Absolutely.
right?
Absolutely. Absolutely. If in some cases, if you don't have the data, let's say it must be because we follow so much of systematic approach, right? So
Mm-hmm.
there might be not anything missing because we identify all the possible causes and we collected the data for it, right?
Mm-hmm.
But still, if you found something coming out of this the creation of the problem definition, and if you don't have the data for it, we need to collect the data for it to investigate or to validate whether there is a real problem or not.
Sure. Thank you.
Okay. So this is the very powerful tool. Though it is a very simple, but it's the, I can say, one of the most powerful tool that will give you the clarity about the our problem, right? What is our problem on which we need to work. Okay, let's come back to the mind map. Now we gone into the detail and we understood the first element of the root cause analysis, which is clear problem definition. Now, in some time, I will also cover the presentations in which presentation on the root cause analysis, and we are also going to understand three root cause analysis for the practical example, the project that we have initiated, where you will get a better clarity on that as well. Okay. Do you have any question on this first element? Is everything clear?
Yes, sir.
Okay, great. So now let's go to the second element, which is identify root cause of significant causes for variation or unacceptable conditions. Now, this is very critical. And if you understood this, it is going to change your thinking towards the root cause analysis, right? Because I've seen many times the identification of the root cause is landing into the only the operator skill or the people skill, right? That should be the one of the important factor, but that should not be only the factor, right? So there is some sequence in which we need to consider what are the categories, right? So that I'm going to cover into the detail, like what are the root cause categories. But before that, as we seen into the 5W2H, many times we need the data, that to have that data or to have the better clarity about it, we are going to use some of the tools. Now, what are the tools that we can use? Here are some of the list of the tools. Now, again, here it is not necessary that we need to use all the tools, right? We can use any one of these tools, or you can use the combination of these tools. It's absolutely fine, right? So let's see what is the first tool. The first tool that is going to help us during the root cause identification is the scatter diagram. If it is not giving you the correct information, or I can say the sufficient information, you can also take it to the next level by using the correlation and regression analysis, right? So that will also help us to do the root cause analysis in better way. The second tool that we can use is the fishbone diagram, right? So that is going to help us, uh, as the Sachin has asked the right question, if we miss the data, right? So where from we get the data? If you use the fishbone diagram, if you already consider many of the factors which is going to impact your uh, response, or which is going to create the problem, we are already going to answer that by using fishbone diagram. The third that we can use the FMA, failure modes and effect analysis. Fourth is the Pareto chart. Fifth one is Viva analysis. And sixth one is hypothesis testing. I can see the most popularly the people are using the 5 analysis. That's absolutely fine. But you can use the 5 analysis once your problem definition is very clear. If you don't have the problem definition clear, please don't start with the 5 analysis, right? So there are the tools that we need to use, like 5W, 1H or 2H, and we can take the support of other tools to have the clear problem definition. Once we have the clear problem definition, then we can use the 5 analysis. Is it clear?
Yep. Yes, sir.
Great. Now let's understand one of the most critical topic from the root cause analysis, which is what are the root causes? in any situation or any problem, we can see there are only five root causes are present. Okay, let me repeat. Irrespective of what is your problem, whether it's related to your product, whether it's related to your service or information that you are going to provide to your customers, suppliers, any problem that falls into any one of these five categories, right? Now, the first category is poor basic condition, right? So I'm going to cover each of these with the help of examples as well. Just look at this picture. What you can see into the picture?
Leakage.
Leakage, right? So there is some
Yeah.
water leakage or some oil leakage
Yeah.
is there. You can clearly see that. Now, if you see, if you go to the basic principles, let's say if you talk about the 5 A's, or if you are going to see the uh, world-class systems, right? So where we need to focus on the basic systems, basic conditions, like there should not be any leakages, right? So if you are going to find out some such a problems, and because of that, it is resulting into our main problem or the major problem that we are going to work on. If it is because of these reasons, then our main problem is because of the poor basic conditions, right? Now, how to address this? Do you have any idea on this? How we can address these poor basic conditions?
Gasket, ceilings.
Yeah, gasket, ceilings. Okay. You, I can say you are bang on the solution, right? You're maybe from technical perspective, it's very sound. But if you see from the system perspective, because we are not just looking for the one-time solution, we are looking for how we can implement the solution, and we will also ensure that at any point of time, all the basic conditions are maintained,
Click to
right?
can apply
Sorry?
click click sir.
Yeah, cleat, right? Cleat can be applied. Yes, absolutely. So it's a part of TPM, right?
Yes, yes.
So it is also can you can cover some part of it. It's also coming into the 5 A's, right? So you can implement the 5 A's and TPM into your processes, whether you are having the manufacturing, pharmaceutical processes, or even if you are having the office, right? You can use these systems into your areas so that we can have the elimination of these poor basic conditions. The maturity of the as the maturity of the 5S and TPM is going to be enhanced, we can see all the basic conditions, problems due to the basic conditions are going to be eliminated, right? So this is the first category of the root cause. Second category of the root causes is the poor operating conditions. Just look at here. What you can see here in this picture. It's very clear, right? So when you're going to
Yes.
work on your laptop or when you're going to study, your back must be straight. If it is not, if you are having like this, then after some time you will be have the pain into your back and neck, right? Now that is a problem. Now that problem has occurred because of the poor operating condition. In many cases, you can see the settings of the machines are something. I can say that threshold, like the machine should not be work beyond 10 psi, but the machine is running at 12 psi, 15 psi, right? So that is automatically going to create the problem because you're not operating under the conditions which is specified for that particular machine. Same is for the software, right? Same is for the, let's say you are having some uh, ex- excess storage into your laptop, right? And if you are going to open some, or if you are going to some do the creative work, it is not going to be too much of speedy because it's poor of basic conditions because there is no space, right, to work on that. So the poor base operating conditions are the situations which are not as per the design of the machine or software or anything, right? And because of that, the problem is getting created. Do you know what are the things that we can deploy here so that we can fix the poor operating conditions? Just as per your thought process. I'm going to provide you some of the examples here as well.
So creating guidelines.
TPM will be play key role.
Absolutely. TPM will again play a role. Yeah, absolutely. Because we are going to standardize the things, right? We must know what is a machine and software capabilities, right? So let's say they are using the machine A, which is having the threshold like 10 psi. So we should not use beyond that, right? So there must be some display or some interlock or some poka, right? So
And
thereby we can use beyond that, right? Yeah, you're
OPL we
saying
can use.
something. Yeah, OPL, I can see it's some level of solution that we can have, but it's better if we can have the. I'm also coming to that point, right? Which level of countermeasure we should have for our uh, root causes. Okay, I'm also coming to that point. Thank you so much, Ramkrishna and Sachin as well. So we can use some of this. We can use the FMEA machine manual or design specification. We can go through it, and we can understand. Okay, what is the machine's design specifications? Machine is designed to operate at which conditions, software is designed to operate under which conditions, right? And we can also look for the line balancing and other techniques, right? So in short, we need to identify what is the best way in which we should operate, whether it's a machine, whether it's a software, whether it's anything, right? So if you are going to consider these points, we are going to eliminate all the uh, possibilities because of the poor operating conditions. Is it clear on these two root cause categories?
Yes, sir.
Great. Now let's talk about the third category, which is deterioration. Just look at the example. What do you see by looking at the example?
Wire got teared off.
Teared up, right? So if you see every part that is going to use into the machine or anything that you are going to use into your softwares or something, right? So there is a deterioration is going to be start, right? Because everything is having some shelf life, right? Now, you need to consider this deterioration, and we need to, by considering this deterioration, we need to develop the system so that before the part or the element is getting failed, we are going to work on it, right? So we can avoid the issues or the problems because of the deterioration. Okay. So, do you know what are the things that we can use for the deterioration?
And also,
It's a poor design of the strain relief.
Sorry.
You're asking what might be the reason for that.
Yeah, reason is there, right? Reason, as I said, everything is having some life, right? So after that, it is going to be deteriorate. But if you want to
Right.
fix this deterioration, right?
time based maintenance maybe.
Absolutely. So you're bang on, right? So these are some of the things, right? I'm just
Yeah.
giving you some of the examples, right? So you can have the preventive maintenance. That means you already know the life or the duration after which you need to do some maintenance, right? Might be it is like cleaning, or we need to check the things, or we need to fix them, or we need to remove them, we need to replace them. So a lot of things that we can do based on the machine manual, machine specification, and our learning experiences as well, right? So that's why it is important to involve the subject matter expertise as well. So we can have the preventive maintenance. We can also use the predictive maintenance, right? So the word just now Ramakrishna has used the time-based maintenance. So we can also call it as a predictive maintenance, where we can also have the multiple things. Like we can have the vibration analysis. That means we are going to fix the vibration sensors on the critical equipments. And as soon as we can see there is increase into the vibration, so it is an indicator that something is bad or something is abnormal is going to happen with your equipment. So we need to check it, and if you found something wrong, abnormal, we need to fix it. Thermography, that is one of the important technique of the predictive maintenance that is used specifically for the PLCs, or if you are going to take the electrical connections and all that. So it is like if you can just take the picture, and you will get the thermograph which is indicating, which is in color red, yellow, green. Red is indicating that particular joint or point is under the too much of stress. Because of that, there is a heat is getting generated, right? So it is a point, or I can say that is a point that is after some time is going to create some problem. So if it is the red, we need to take the immediate action. If it is yellow, we can monitor it, and we can fix it before it is going into the red zone, right? So that is one of the technique we can use. Oil analysis is also used in some of the mechanical equipments where you are going to use the oil, like we can say the gearboxes, right? So where After certain period, we need to take the oil from the gearboxes. We need to check it for the presence of the foreign particles. And based on that, if you can see it is perfectly fine, we can use it, so we can continue. But if you found there is some wear and tear, then we need to replace the oil. At the same time, we need to investigate what is going to happen into the like entire system, right? So this is the predictive maintenance. That means we are going to consider, or we are going to attack on the deterioration before it is creating the problem for us, right? In some cases, we also know what is a product life cycle test. Let's say, for example, if you see the it is normally said that if you are using the laptop, the product life cycle is of 5 years, 3 years in some cases. So if you are going to use beyond that, it is not going to support the systems, whatever the applications that are coming, right? The memory and like the speed and other things, right? Because of that, we need to replace it by the new technology or the new things, right? Specifically, it is true for the gadgets. Even if you talk about your mobile, it's same applicable. So that is a product life cycle test. Another is like the calibration of the equipment. Like periodically, we need to do that because there is some deterioration that is going to happen. This is not a limited list, right? I'm just giving you some of the examples to give you about the clarity, like what is the deterioration and how we can address that deterioration. Is it clear about these three root cause categories?
Yes, sir.
Okay. The interesting thing, if you can see, I didn't talk about the operator skill at this point of time, right? We just focus on poor basic conditions, poor operating conditions, and deterioration. Now, the fourth element is weak design, right? Now, how we can say that there is a problem with the weak design, right? If you can see, there is a one element that is continuously getting failed. That might be the thing, like it is because of the weak design, right? So you can involve your subject matter expertise and we can see why that particular element or link is getting frequently failed, right? So do you know or do you guess what are the things that we can implement on this in this situation to address the issues of weak design?
FEMA we can use TPA.
Okay. Yeah, we can use that as well, right? Uh, yeah, these are the some techniques we can use. We can use the design for Six Sigma, right? We can use the DOE to identify whether the settings and everything is fine or not. And we can also involve the your design experts, to your design engineer, manufacturing engineers to understand why that part is getting frequently failed. So is there like we need to change the raw material of the part, or we need to increase the thickness, or we need to provide some modification like curvature or something like that, right? So we don't know what is the modification that we need to do, right? So we can involve the subject matter expertise like design experts. We can also involve the operators or the experts who are going to work on that particular process so that we can work on this big design part. Clear up to this point? Any questions on these four categories?
Hey Vijay, you said just use the DFSS for if it is in case of weak design, but you collected the data and all the it's just examples for the root cause category, right? And it's I
Yeah,
mean,
as I said, I'm going to explain you with the help of our model project. So we have the multiple examples there, right? So I can
okay,
say there are three root cause analysis are there. So I'm going to discuss in that as well how to identify which category it belongs to, right? But generally, weak design is the area where you can see there is a frequent failure of some element, right? And in that case, we can clearly see that if it is the same element is failing multiple times, might be right, might be the case of the weak design. So you can discuss with your subject matter expertise, your team, right? So this part is frequently failed, so can we do some modifications into that so that we can work on it, right? One more thing, if that part, which is, let's say in some cases there is the safety element that is getting introduced, and if that safety element is frequently breaking, right? So it's not a weak design. We need to think about what is going to happen into your system, right? We need to work on that,
right,
right? Because in some cases there is the we can call it as a element, right? That's a safety element that is getting introduced, right? To avoid the big failures, right? So you can see there are some safety pins that is included into your compressors and all that, right? So as soon as the pressure
Right.
is abnormal pressure is getting built into your compressor, that wall is automatically open. That's a safety wall, right? So if that is getting automatically open many times, it's not like it is a weak design. There is something bad is going to happen into your compressor, right? So it, as I said, there might be the weak design problem. So we can investigate that and we can have some modifications into your element design so that we can fix this issue.
So you mean
Is clear?
that is going to be another project?
No,
Because
no,
we are
no.
in analyze phase, right?
Yeah. No, this is not another project, right? This is the part of the root cause analysis, right? Uh, if you going to identify what is the real root cause, right? So real root cause must come out of these five categories that I'm going to explain, right? One is still I'm going to explain, but you should go like this. Think about whether there
Okay.
is an issue of basic condition. No.
Oh, okay.
If it is
Okay.
if it is because of operating conditions, no. If it is because of deterioration, if it is because of weak design, if you have all these conditions intact, right? Then we can go for the fifth category.
Okay.
Okay.
I got it.
Thank you, Raj. Thank you for asking questions. So let's go to the fifth category, and this is poor skill, right? So we are not neglecting the expertise of the human being, right? Or the operator or human skills, right? So as human is there, we can see we are, I can say we are not doing deliberately, but our nature is like that. In spite of we are trying many times, we can do the mistake, right? Or is mistakes happen from our end, right? So to avoid that, we also need to work on the skill part. But the biggest mistake I have seen in many of the root cause analysis I've seen that directly starting with a poor skill, right? They're not thinking about what is going to be wrong into this one, two, three, four. They directly start with the poor skill, right? And you can see the countermeasure is always fixed. In that case, the operator training is provided and the problem is solved. It's not going to solve the problem. Why? I'm going to cover that into the countermeasures as well, right? That's our third element. Okay, now let's come back to this element and let's talk about the poor skill. Skill is also important things if your process is not totally RP, it's a robotic automated process. If it is depending on the human skill, the skill is one of the most important thing. And because of that, you might see there is the problem. Now to avoid that, or I can say minimize that, we can work on the education and training and continuous skill development programs. So we can create the procedures, we can have the clear work instructions, we can have the training of them, like we can have the theoretical trainings, on the job training, their evaluation. So there are many things into that, right? So thereby we can evolve the skills of the human being, which is involved into that process, right? So the education and training and continuous skill development is going to help us during these situations. Now, if I am to summarize, irrespective of any of the problem that you're going to face, right? Your root cause must belong to out of this five, right? And the fifth category that, as I said, it's a human element. As I already said, as how much we can try, the mistakes are going to happen from our end, right? So we need to focus, we need to ensure that the system one, two, three, four, we are going to fix it, and then we are going to work on the poor skills as well, right? These are the five root cause categories. Is it clear?
Yes.
Great. So I'm sure you got the more clarity on root cause analysis. And also, this is one of the biggest mistake that professionals are doing. And you can see many times you can see the lot of efforts are getting introduced. The team is working on it, but still you're not getting the results. One more thing is here, like you can see as we are going to do the lot of data collection, we are doing the analysis uh, and investigations. There are many things which is involved into any Lean Six Sigma project or any of the problem solving process. By the time we reach to the root cause analysis, we can say there is a pressure of the timeline to implement the effective solutions or implement the solution and close the project, right? So for that purpose, the proper planning is very, very critical, right? Even it is desirable that we can extend the project timeline if it is genuine by a week or two, please do that, but don't compromise on the root cause analysis, right? Because that is ultimately going to decide the future or the benefit for your project. Okay, is it clear up to this point?
Yes, sir.
Great. So now let's talk about the third element. The third element is the initiate countermeasure and its tracking, right? Now, even you do the root cause analysis. Now, if you're going to conduct the root cause analysis by the methodology I shown you, it is automatically driving you to implement the countermeasure which is worth of implementing, right? Because we are going to identify what is the problem with respect to the whether it's related to the basic conditions, operating conditions, reiteration, weak design, and we are going to work on that, right? Still, if you go for the implementation of countermeasure, you need to understand that there are 6 levels of countermeasures, right? Sometime before we also talk about the OPL, right? So we should not have countermeasure as OPL implementation as our first countermeasure, first level of countermeasure. Why it is, I will explain that in some time. So when we are going to implement the countermeasure, this is the tracking sheet that we must have. You will get that inside our training, where we are going to mention what is the root cause analysis number, right? So during the project, whatever the root cause analysis we are going to do, we are going to measure or must have some unique ID. Why it is, let's say in the future, if the problem is going to be repeat, you can come back and we can check what is the analysis we done. So instead of reinventing the wheel, we can just check what was the root cause analysis that we conducted, what was the root cause we found out, what is the countermeasure that we have implemented, and we can just simply check whether that countermeasure is in place or not. Might be the problem has reoccurred because the countermeasure that we have executed is removed or is not in place. And because of that, the problem has generated again. So if it is that is the case, we need to check why that countermeasure was missed or it is not executed or why it is got eliminated. We can just fix it and no need to do the uh, I can say root cause analysis again. But if it is the new case, we need to go for the new root cause analysis, right? So that's why the tracking of the root cause analysis and the countermeasure is very, very important. We can have that. What is the countermeasure that we are going to execute? Who is responsible for that? What is the target date for the execution? And you must have the some review dates period to the due date, right? So we should not directly review what is the status of the countermeasure on the day of completion. We should have at least period to that, like 2 or 3 reviews, so that we can check whether that person who is responsible having all the resources that are required for the execution or the implementation of the countermeasure or not. Might be he needs some additional resources like the manpower, the material, right? Sometimes it might be required additional money. We don't know, right? So to check that whether the implementations is going in line as per the plan, we need to check with the periodic reviews, right? So that we must have the next review date. We must also have updated status of it, and if it is there any comment specific to that countermeasure, you can add it here, right? Now, it is strongly recommended that you must have countermeasure tracking sheet for all your root cause analysis. There should not be multiple countermeasure tracking sheet. There must be only one tracking sheet, and you can have the multiple root cause analysis formats, so that whatever what is the output or whatever the output of your root cause analysis, that must be come into this countermeasure tracking sheet. Once you conduct any root cause analysis, come back here and update this. What was the root cause analysis number? What was the root cause we have identified? What is the countermeasure that a team has decided? Who is responsible for it? What is the target date? And before that, when we are going to plan the first review, the status and what is the comment, right? So we need to create this countermeasure tracking sheet. Is it clear?
Yes.
Great, thank you. Now, as we discuss about the countermeasure tracking sheet, let's talk about the countermeasures that we are going to decide, right? So there are 6 levels of countermeasures. Let me go to the image. Can you see this image clearly?
Yes, sir. We can see.
Okay.
I can see it.
Yeah, thank you so much. Now, Please understand here. The lower the level of countermeasure, the weakest is the countermeasure. Right? You can also see that by the color. The red color indicates that this countermeasure is not going to address your root cause. So your problem is going to be repeat and again, right? So as you go to the level 2, you can say it's somewhat red. It's not a dark red, somewhat red. That means the problem is not solved. It is going to be repeat. Level 3, yellow. That means problem is solved to some extent, but problem is going to be repeat again and again. Level 4 and 5, 6, you can see somewhat in green, moderate green and dark green. So that indicates the problem is going to be solved in by significant manner, right? That means if you're going to define the countermeasure for your root causes, that must be at level 4, 5, and 6. It should not be level 1 to 3. Yeah, 1 to 3 can be at your immediate countermeasures, right? Till the time you are going to execute the 4, 5, 6, because the level 4, 5, and 6, though I am going to say that these are the best countermeasures, they are going to solve your problem significantly, they are also going to take some significant resources as well. They will take more time, they will take more energy, they will take more money, they will take more resources, right? Because they are not a quick solutions, right? We need to think on it and we need to execute them. I'm also going to take example and I will also explain during the model project, right? Where we are going to see the three root cause analysis in very detail. At that time, I will say, I will mention what is this level 4, 5, and 6 in those cases as well. Okay. Now let's come back here. What is level 1? Just read the description. Remind the person of the way to do the check correctly. And that is the countermeasure I can see in many of the root cause analysis formats. They identify the root cause and they implemented the level 1 countermeasure like PM card, OPL, discipline, retrain, punishment, something like that, right? So these are the examples of level 1 countermeasures. Now, if you're going to execute these solutions, if you're going to execute the countermeasure at this level 1, I'm not saying that the problem is going not solve. It is going to be solve the problem, but the problem is going to be repeat and again and again because there is a total manual control, right? And this is called as a weak countermeasure. We can start with, I can say for immediate implementation, but our goal must be countermeasure at level of 4, 5, and 6. Now, if you go to the level 2, double check that the person has remembered to do it the correct way, right? So instead of relying on the person, here is also the double check, right? Again, that's I can say one kind of waste we are going to add, perform an audit, right? So there is one person, but whether that person is going to do the task in the correct manner or not, we are going to check it periodically. That is the audit. Though it is a better than the first level of countermeasure, again, it's not guaranteed that the problem is going to be addressed. Might be we can investigate that whenever we are going to do the audit and at the same time the problem is there, we can find it. But when we don't have the audit and that time if the problem is there, we cannot identify that, right? So again, this is the weak countermeasure. Is it clear up to this point? Do you have any questions?
No, sir. No question.
Okay. Yeah, clear. Thank you so much. Now, let's go to the level 3. In level 3, that is better than level 1 and 2. And we can see when there is a evolution of the industry 4.0, machine learning, and I can say the artificial intelligence as well. This level 3, level 4, and above countermeasures implementation is somewhat easy, right? And we are always going to start with the level 3. That is a great thing, where we constantly remind them at a glance of the correct way. Like we can have the visual controls, gauge markings, signage, floor markings, so that it is helping the people, right? Even they forget it, by looking at the marking, they can get to know that, okay, we should do like this, we should not do like this. Okay. So this is the third level of countermeasure. Level 4, as the name indicates, and it is in green color, we can say is a foolproof design because here we are going to work on the Pokayaki, right? Make it difficult to do it in the incorrect way, right? So even the person wants to do it, he cannot or she cannot do it, right? So that is a foolproof design. We can call it as a POCA. The fifth is do the automation so that there is no human element, no error, right? So we can mechanize the operation. We can implement the automation into that. We can implement the robots and all that. Still, we can say there is no guarantee like problem will not be there. But we can say that is reduced to significant manner. And the last one is eliminate the operation. Because of some problem, there is a case, right? There is a situation. So if you eliminate that entire element, then problem is not going to be repeat. Like design out the need to do it. If you want to do that, right? We need to play with the design. The level 6 countermeasure is the best one, but it also involves a lot of time, energy, money, as I already told to you, and it is going to fix the problem permanently. Is it clear? Do you know any simple example of level 6 that is coming in front of your mind? All these 1, 2, 3, 4, 5 we can see on daily basis, right? I'm talking about the special at level 6. Do you remember anything
Yeah, the
that
poke
belongs to?
or completely eliminate from the without
Yeah.
manual like implementing the design like foolproof.
Yeah. Do you know any example of this?
Automation, you say?
Automation will come to level 5.
The example.
Okay. Let me give you some example. Simple example that you can understood. Okay. Do you remember some days back, there was the tube with tire with tube. Do you know the situation?
Yeah.
And because of that, if there is something is going to happen, or if you're going to go in off road, right? And if there is some, uh, we can say the pointing things like the some screw or something that is going to be purged, right? So your tire is getting punctured. Now, if you see the root cause analysis done in such a way that they identified the problem is going to happen because of the tube. If you can remove the tube, right? So we can enhance the capability or stability or reliability of your tire so that it will not have the puncture, right? Now the tube has getting removed and the tubeless tires comes in picture. Now we can see the level of puncture that is going to happen, right? So we completely eliminate the element. Because of that, the puncture is going to happen, right? So there are many such examples that we can work on it. That is also possible in your case. If you are going to think about your problem, so there are always these 6 levels of countermeasure are present, level 1 to level 6. Depending on what is the criticality of the problem, how much time you have, how much resources you can implement that by considering the criticality or severity of the problem, we can implement the appropriate level of countermeasure on it, right? So here is some short, uh, yeah, thank you so much. So this is a short example here. Okay, so I'm just taking some traffic example. So you can understood all these 6 levels of countermeasure into it, right? You can see here. The level 1 here is remind the person of the way or do the check correctly, right? So there is no system, nothing. The person who is going to drive, he or she need to check, and then she can go ahead. So there is a problem like car is going from this side as well and that side as well. Okay, but yeah, there can be the accident happen, right? Now, the second level is like we can put the traffic police there, like we're going to check whether the uh, the car drivers who are coming at that point, stopping, waiting, and then after seeing them they are going forward, right? So we can have that level of things. We can put the policeman there. Now here is we put the auditor. Now the problem is going to be solved, no, right? But yeah, somewhat the reoccurrence of the problem is going to be reduced. Now the third and fourth level, we can see there is the traffic lights, right? So that is clearly indicate that when there is a red, when there is a, they need to wait, they need to stop, or they need to like go, right? So just looking at the traffic signals, they can plan. And you can also see that there is this circle, right? Round around. So they can simply, when they are want to go, they can just go through it, right? So thereby there is a possibility is going to be reduced, not eliminated. Now you can see the fifth and sixth level, like we are going to have the one ways, right? So there is, and it's a clearly defined that only car will go into that direction, something like that. The sixth level, like we can have the flyovers, right? So there is no thing like you need to wait or you need to uh, there is a possibility of accident. It's completely eliminating because there is a flyover now, right? So there is a, I can say the square case is completely eliminated. So if you look at the problem, always there are six levels of countermeasures are present, right? If you want to deliver your project to its full of capacity, full of effectiveness, right? Or I can say the highest results, it's very important that you must have the countermeasure at least level 4, at least level 4. If it is level 5 and 6 possible for you, and that permits, you must target 5 and 6 as well, right? But considering all the effective and optimization of the things, you must have the countermeasure at least level 4. You can support that with the level 3, 2, and 1 as well for the temporary solutions or temporary countermeasures. Is it clear?
Yep.
Great. Now, the last thing related to the countermeasure is don't forget to use the hypothesis testing, right? As we also seen the 2 weeks back, why it is important to focus on the hypothesis testing and what is its criticality, right? Hypothesis testing is one of the tool that we are going to use. Even we are going to start the project and after it is going to be used uh, after the end of the project as well, right? This is very powerful tool. And we also need to use that here to check or to validate countermeasures. So whatever the countermeasure that we have executed, whether that countermeasure is effective or not, that we need to check with the help of hypothesis testing. How we can check? We can see what is the earlier scenario and what is the after scenario. So is there any significant change? So we need to collect the data for it, and based on that, we can say whether our countermeasure is effective or not.
सर, जो हमारा मॉडल प्रोजेक्ट है उसमें वैलिडेट किया है क्या उसका रूट कॉज विद हाइपोथेसिस टेस्टिंग?
Yes, yes. I will
Okay,
explain that.
great,
Okay.
great. Yeah.
Great. So now let's come to the end of this, right? That means we are going to cover the first part of this. So once we complete this overview of the challenge 8, what are the tasks we need to complete? Let me finish that first. So what are the challenge 8 tasks? If you are enrolling that as a part of green belt, okay, so go to the training for the chapter 16. That is completely focused on the root cause analysis, right? I will also show you the presentations, the slides and all that, and what is the approach that we need to follow during the learning. And from the assessment perspective, there is no new assessment on in this week, but just complete the assessment 4 that as a part of the challenge 7 as well. Uh, you need to complete assessment 1, 2, 3, and 4. Okay. For the black belt, uh, for the training perspective, as I already said in last week, we talk about the multivariate analysis as well. So complete the training for it if you have not completed. Gap analysis and waste analysis, these are the other tools, 2 tools that we need to learn, right? As a part of the black belt. I will also show you the slides for it and how to learn it in some time once we complete this first segment. For the assessment, there is the new assessment that is getting added to the black belt, which is assessment 9, and that is totally focused on the hypothesis testing as well as the root cause analysis, right? So as a black belt, what are your capabilities and how we are going to solve or handle the situations? To check that, we have created the multiple choice questions and I have created the multiple situations, right? So you need to put yourself into that situation and answer what is your response to that particular situation, right? Once it is done, submit it to me. So I will review it and give you the feedback. Okay. So this is the main, I can say the learning exercise for you for the green belt and black belt. Okay. You will also see that these details below the recording of the today's session in our learning management system, right? I will share the link into our WhatsApp group once we complete this entire training. Third, this is regarding the application, right? Make the problem definition clear before starting RC using 5W2H or 5W1H, right? Now, this is the thing that you need to use for your project, right? So please go to your project, right? Till the time, whatever the steps that we have completed, we have identified what are the significant factors, right? So in our model project that I'm going to take, right? So in that we identify there are three significant factors, three significant causes. Now we are going to take it to the next level by using root cause analysis. I will explain that in detail. Same you need to do for your project, right? And once it is done, you can share with me or you can schedule a call with me to discuss in detail. Make the problem definition clear. Then find the root cause for your project and validate using hypothesis testing. So there are two things. One is make the problem definition clear. Once it is clear, conduct the root cause analysis for it. Maybe you can use the 5 analysis for it. And by using 5 analysis, identify what is the root cause, validate whether that root cause is correct or not, right? And then we can go for the implementation of countermeasure. Implementation of countermeasure, we are also going to discuss in very detail into the next week as well, where we are going to start our improve phase, where we are going to talk about the implement and validate, how to implement the solution and how to validate it, right? Just to give you an overview, I explain or given you the short introduction of countermeasure, but we are going to discuss that in very detail into the next week, where uh, that will be the challenge 9, and we are going to discuss about how to implement the solution and how to validate that the solution that we executed is valid and effective or not, right? So that we'll see into the next week. And the one thing that is, I always request to everyone, please schedule a one-to-one call with me. And might be that is for the 10 minutes or 15 minutes, but please schedule a call at least once in a week with me and discuss what is your progress. Do you need any help in your understanding of the concepts, learning the things, or practical execution, application of the tools, or anything that is holding you back? Okay, so that we can discuss into this one-to-one call, and I will help you to uh, get the answers or solutions to it, right? And this is one more opportunity to you, right? If you want to share something, like you've done the great work on your project and you want to share that with the other team members as well, as some of the other team members are always sharing, if you want to share it, just let me know 15 one day before that you want to share something. So I will create a slot for you for the 10 to 15 minutes where you can share your knowledge or whatever the work that you have done. So that is not also only going to help you to present your knowledge, but that is also going to help your presentation skills, your confidence level, and in other way that is also going to help the other community members to understand, okay, how we are going to deploy the tools, and they can also get a real life examples, right? Though we are going to take the model project, the real projects that we are going to take is the real project, right? So we will have the many fold, I can say, learnings into that, right? So that's why this is very important. Is it clear?
Yes, sir.
Okay, great. So with this, we have completed our first, I can say, the part of the weekly session, which is the learning of one of the important topic and how to learn it, right? How to execute it. That we have done. Now let me help you to understand how we are going to execute that on our model project. So let me stop sharing this. Amit, glad to see you. How are you?
Uh, Hi, sir. Hi, I'm good. I'm good. Thank you, sir. Thank you.
Okay, great. So let me open the Excel file. Where we are going to discuss about the root cause analysis. Okay, so the once we see these examples of the root cause analysis, then afterwards I will also explain that what is the portion that we need to complete for our A3, right? So I also updated the A3 report that we are going to consider or that we are going to review as a part of this implementation. Let me just share the screen. Let me know if you have any question till the time the file is getting open. Or maybe you can share something related to your work. Can you see my screen?
Yeah, it's coming up.
Yes.
Yeah, I can see.
Okay, great. So let me click on the sheet number 1. Okay. Do you remember what are the 3 factors that we identified as the significant causes by using the correlation regression analysis and the exploratory data analysis tools like hypothesis testing last week in last 2 sessions? Do you remember that for a model project?
I was not there. So
Okay. Okay. So might be you can go through the recordings and you can catch up, right?
sure, sure.
So there are 3 factors that we are seeing. Okay, let's discuss 2 here. The first we identified as the inconsistent injection pressure, and because of that, we got the problem, right? We have seen that. Second, we seen like the tool wear out, right? These are the 2 significant problems or 2 significant problems or causes we have identified, right? So let's look at this injection pressure. Can you see my screen on the injection pressure?
No, I can see only the Excel sheet.
Okay, let me close the presentation so we'll get some bandwidth. Now, can you see it?
Yeah. I'm seeing only that injection pressure or spreadsheet
Right.
or something.
Yeah, injection
Yeah.
pressure, right. Okay.
Yep.
So I'm going to share this now. Okay, look at here. Is it readable to you?
Yes.
Okay,
Yes, sir.
just look at this here. Injection pressure, that's the one of the significant causes we identified. And the problem is like we can see because of that we have the higher defect percentage. We've seen that that's a 6.15. So we can ask the question like why are there are high defects, and we identify that because the injection pressure is not consistent across production runs. So that we also seen during the run chart, and we also seen it during the box plot, right? So there is the inconsistent injection pressure, and because of that we are having the uh, more defect percentage. Now we can ask the second question: why is the pressure inconsistent? Because the machine pressure regulators often go out of calibration, right? So this is just an example, right? So just try to understand the thought process behind it, right? So we are going to ask the next level of questions like why do they go out of calibration? Because preventive maintenance is not performed regularly. Why the maintenance not done regularly? Because there is no scheduled maintenance calendar or checklist for this specific machine component. Why there is no checklist? Because the current maintenance SOP does not cover calibration of pressure regulators. So we can see this point is completely missing for the calibration of pressure regulators. Now, which kind of root cause category it is?
System level 4.
Deterioration.
Because the current maintenance SOP does not cover calibration of pressure regulators.
System related.
Yeah, but is it a weak? It's a poor basic condition, poor operating condition. Is the
Deterioration, sir.
Deterioration or it's a weak design.
It's a
See,
poor basic condition.
deterioration means there is something already there, now it is getting deteriorated. That's a deterioration, right?
I
You can
think
see
it's
Poor
poor basic
operating
condition.
conditions. Poor operating
it's a
conditions.
it's a poor operating conditions, right? Or you can say it's a poor basic conditions. It can come into both categories. If you see the basic condition from system perspective, operating conditions, yeah, it must be there, but it is not there, right? So you can call it as a poor basic or poor operating conditions. It's absolutely fine. So this is a root cause of the thing, right? Maintenance SOP lacks pressure calibration procedures. Now look at here. I have created the three levels of countermeasures. I didn't put the OPS and all that, like level 1 to 3 are very big. So we are not going to discuss about that. What is a level 4 countermeasure in this? Revise maintenance SOP, introduce special calibration checklist and schedule, right? So if it is there, then we are going to follow it, right? So that's a level 4. Maintenance SOP is there, which introduce pressure calibration checklist, and also there is a schedule, right? So that's a somewhat I can say very good countermeasure. If we can have the automated computer managed the management system, right? So alerts and assign owner for calibration completion, right? Then unless and until it is getting followed, it is not going to be updated into the system. So you need to do it. Only that it is going to be updated, right? So this is the next level of solution, I can say. So this is better than the level 4, but this is very good. We can talk about eliminate the need of manual calibration, right? Use the pressure sensors with auto feedback loops. Machine automatically monitors and adjusts pressure during production. No operator calibration is required, right? Now, if you see, this solution is not easy, right? Because you need to create the, you need to implement the sensors that is with the auto feedback loops, right? And there are some automations and that is also getting into some resources. Money, time is also getting into it. But this will give us a very good results. Is it clear?
Sir, do we need to place a trigger in the system? Detectability, I mean to say.
Yeah, that will come into this.
Control.
Yeah, this is level 5,
Okay.
where we can have the system to check it, right? So there will be the alerts. So it will automatically give you the alert, okay, the pressure calibration is due, we need to complete it. And unless and until you are going to do it, it is not going to close it, right? So that's an alert, and it is also assigned the owner, right?
Yeah.
So who needs to do it? This is due, and the person needs to do it. And what is the status that we can clearly see. So there can be some reports and something that is going to be sent by the system automatically. So these are the calibration which are pending for calibration, right? And if we can have the pressure sensors with auto feedback loops, the machine automatically monitors and adjusts pressure during production. No operator calibration is required, right? But that also requires, I can say, the more technical knowledge, more expertise, and all that. But that also we can execute. Let's take another example here, tool beer level, right? So we can ask the first why, because one tools are still used during the production, and because of that, we had the tool uh, increased defect percentage. Why are the one tools not replaced? Because the tool wear is not measured before or after production runs. Why tool wear not measured? Because operators are not trained to assess or record tool condition. Why they are not trained? Because training is only focused on basic operations, not on the tool diagnostic. Why the tool diagnostic excluded from the training? Because there was no prior analysis to link tool wear with defects. So then we can say there is no knowledge that tool wear is going to be resulted into the defect increase in defect percentage, and because of that, everything has got happened. So it's a lack of training and SOP on measuring and responding to tool wear. So this is the root cause we got. Which level of root cause it is? The root cause belongs to which category?
Poor skill.
Poor skill will come when, yeah, it can also come the poor skill, but more than poor skill, we should go to the poor skill at the last, as I said, right? We can say that there must be a system, right? There must be the basic thing that whenever you are going to use the tools, that people or the operators who are going to work must have this knowledge, right? Must have some kind of training. So is the system loophole, right? It's a basic condition, right? So is the poor basic conditions. To avoid that, what we can have, create SOP for tool wear measurement with defined limits that we can do. We can conduct the formal training plus competency certification plus visual wear indicators. That can be the level 5. And the 6 can be like we can have the automatic wear sensing, right? Vibration sensors linked to the predictive maintenance software. Some time before, I also talk about some of the predictive maintenance things, right? So like vibration sensor that will explain that as there is increase in the vibration, that is also explains that there is a tool wear out. So we can immediately stop uh, or we can immediately get the trigger and we can work on it before it is getting failed. Is it clear?
Yes, sir.
Yes.
Great. Now, if you see this implementation on our A3 report, let me open the A3 report as well. Can you see my A3 report?
I still see the spreadsheet.
Okay, let me,
Now I can see it. Yeah.
you can see it, yeah, okay. So we can see here till the last week, we have completed till this point, right? So we have identified, we done the cause and effect diagram, and we identified these are the two significant factors. Three factors are there. I highlighted two. One is the improper tool condition, and there is injection pressure, variation into the injection pressure. So I just add one of the example here. Whatever the RCA we have done, I just added here. The injection pressure is not considered across production runs. The production pressure regulators often go out of calibration, right? So we identify the root cause is the current calibration SOP does not cover calibration of pressure regulators. And I also added for the second one, the lack of training and SOP on measuring and responding to tool wear. The just two RCS that we've seen, I just added the information here, right? Is it clear up to this point?
Yes, sir.
This is just the things that I'm going to update here. A3 is what is our summary report, right? So we are going to summarize everything here. Now, the next thing is here. We can mention like what are the attachments that we are going to have. Like we have the capability analysis report, fishbone diagram, and the root cause analysis just now we done. We can provide that into the attachment section. Now we need to have the decision and agreement, right? And after that, we need to update here. So whether we should go for the implementation of solution or not. So we can see here the discussion has happened, right? Considering the increase in percentage defective, team and management agrees to implement a solution at level 5 and 6 to ensure best result from the project, right? So these are the two countermeasures that you can see. Level 6 countermeasures I've taken and we are going to execute it. But to support these two countermeasures with for the immediate quick wins, right? Or for the, I can say the immediate implementation, I have also implemented the another one countermeasure. So this is the list of countermeasure, right? Where we are going to explain what is a countermeasure that we are going to execute. And we are going to compare each of these countermeasure on three categories. How much easy it is, how much cost required for the implementation of it, and what is the impact of it, right? How to rate them? We can see here is simply there is a scale. If it is very hard to implement, we can say it's a score 1. If it is moderate, we can say it's 3. If it is very easy to implement, we are going to provide the score 5, right? Why we are giving the 5 score for easy implementation? Because we are going to prioritize it, right? That's why there is a high score for the easy implementation. For the cost, we are going to apply the same logic. If it is very expensive, the score will be 1. If it is medium, 3. Very low cost or required no cost at all, it will be level 5, right? So we can add the score for it as 5. For the impact, if it is low impact or small impact, we can give the score as 1. If it is medium impact, we can give the score as 3. And if it is a huge impact, we can give it score as a 5. So in same way, whatever the rating that we had seen here, we need to provide that rating for each of the countermeasure that we have decided, right? Let's say for the first countermeasure, revise SOP and checklist for the calibration, right? That's a level 4, but we can see that is very easy to implement, required no cost, but just the efforts are required. The team needs to come together and they can work for it and they can create it. And impact is also very high, right? So what will be the score for it? We can just need to multiply all these three, 5 into 5 into 5. So there is already the formula here. So that will give us a 125 as a impact score. Higher the score, we need to execute that solution earlier. That will be our priority number 1, because we are going to consider how much easy to implement, what is the resources or cost is involved, and what is the impact of that countermeasure. If you see for the second countermeasure, everything is moderate. No, it's easy and cost are moderate, impact is high. So score is coming as 45. The third one is, though it is difficult to implement and costly to implement, it is having the huge impact. So we need to consider that as well. So these are the 3 countermeasures that we are going to execute. Now, after that, we need to create the plan. Right? So who are the team members, and maybe I will discuss that into the next week, right? Because implementation and validation we are going to discuss last week, uh, into the next week. And after that, what are the results and how we are going to capture the other things that I will explain once we move to the next challenge. Is it clear? What is a portion that we need to complete for your A3 as well? So we need to complete the countermeasure section till the identification of the countermeasure and identifying the uh, priority score for them.
Sure. Sir, will you going to cover the hypothesis testing for the root cause analysis?
I think we will cover that implementing validation, right?
Okay.
It's
Yeah.
the next week. Yeah. I
Okay.
have already the data and everything for it, but it will be, I think, too much
Okay.
for you.
Sure. Sure.
Okay. So we will cover that in next week because we have the dedicated session. In that, we are going to talk about, okay, we define the solutions here, right?
Right.
Right. But implementation is not like you just go and implement. There is a lot of things is involved, like it involves the preparation, it involves the approval, it involves the justification of your case, right? So there are a lot of things which are involved into the implementation. So we'll cover everything in detail. And also there is one critical concept that is called as a management of change, right? So before implementation, we also need to work on the management of change, because if it is not there, it will create the confusion among the team members and across the organization as well. So for that purpose, we also need to have the management of change. So all these critical things we will discuss into the implementation section next week. And after that, I will explain how to validate. Once you implement that solution, how to validate with the help of data and hypothesis testing, I will explain it. I will also explain how we can use the control chart and all that as well. Okay, on that. But this week, just focus on identify root cause of the problem, identify the countermeasure for it, and just have the priority ranking, which countermeasure we need to execute. How to execute that and how to validate that, we will see into the next week.
Sure.
Clear?
Yes, sir.
Great. Thank you so much. So the next part is we need to go for the presentations. But before that, let me stop the live streaming on YouTube. Just let me know, just let me update everyone who is watching live on the YouTube. So thank you so much for your valuable time. And we covered the root cause analysis in very detailed. You must understood, or you must got the greater insights about this. Okay.